Start today's seminar presented by our honor student. So first of all, I invite Arnab and Kishanu to present their talk.
Hello everyone, I am Kishanu from second sem. Today we are presenting special theory of relativity. Introduction. The special theory of relativity or special relativity is a physical theory which states the relationship between space and time. Special relativity implies consequences of mass, energy, equivalence, relativity of simultaneity, length contraction and the universal speed limit. The conventional notion of absolute universal time is replaced by the notion of a time that is dependent on the reference frame and spatial position. Importance of special theory of relativity. One of the main tenets of special theory of relativity is that the laws of physics are the same for all the observers in uniform motion relative to each other. This is known as the principle of relativity. Another key idea of special theory of relativity is that the speed of light is constant and same for all the observers regardless of their relative motion. The theory also introduced the concept of time dilation. Time passes more slowly for objects that are moving relative to an observer. Special theory of relativity also introduced the idea of mass energy equivalence as described by the famous equation E equal to mc square, which states that the mass and energy are interchangeable. Overall, the special theory of relativity has had profound impact on our understanding of the universe and has led to the numerous technological advances such as GPS system, which rely on the precise measurement of time and space. The two postulates of special theory of relativity. First one, the law of physics are the same for all observers in uniform motion relative to each other. This means there is no preferred reference frame in this universe, whether you are moving at a constant velocity or standing still. The laws of physics appear same for you. The second one, the speed of light in vacuum is always constant and same for all the observers, regardless of their motion. This postulate is often referred to as the consistency of speed of light. It means that the speed of light is an absolute limit beyond which nothing can travel. It also implies that time and space are not absolute but are relative to the observer's motion. In this part, we are presenting the special relativity of theory. The main two parts, they are time dilation and mass energy equivalence. Now I am inviting Arnab and Kishanu to presenting the rest of the part.
Time dilation is one of the most important aspects of special theory of relativity. So time dilation states that time dilation is a phenomenon in which time appears to pass slower or faster or faster for a compared object which is at rest. According to the theory of relativity, time is not absolute, but it is relative to the observer's motion. As an object moves faster, the relative velocity with respect to the stationary observer increases, and time appears to slow down for the moving object. This effect is called time dilation. There is a mathematical expression for the time dilation, and that is T is equal to T naught divided by under root of 1 minus v square by c square, where T is the time observed, T naught is the time observed at rest, v is the velocity of the object, and c is the velocity of the light. Where one of the most famous examples of the time dilation is twin paradox. Suppose one twin stays on Earth. Here one twin is on Earth and when the other travels in a spaceship at nearly at the speed of the light. When the traveling twin returns to Earth, they will have age less than the twin who stayed on the Earth. That is the person who stays on the Earth, and then the other twin which is traveling with rocket and then comes back to Earth. he will then the twin which is at spaceship, he will be younger than the twin will be station. Time dilation has been observed in many experiments, including the famous Heffel-Keating experiment, which measured the effect of time dilation on atomic clocks during airplane flights. Time dilation also plays a significant role in modern technology such as GPS systems, where precise timing is essential for accurate positioning. Now, the famous mass energy equivalence. The concept of mass energy equivalence is one of the most fundamental principles of modern physics. The mass energy equivalence states that mass and energy are two forms of the same thing, and they are interchangeable. This idea is encapsulated in the famous equation E is equal to mc square, where E is the total energy, m is the mass, and c is the speed of the light. The equation suggests that a small amount of mass can be converted into a very large amount of energy, or vice versa. This was first demonstrated by Albert Einstein in 1905 in his theory of special relativity, and later confirmed by experiments in nuclear fusion and fusion. The mass energy equivalent principle has a numerous practical applications such as nuclear energy. In nuclear reactions such as fission and fusion, a small amount of matter is converted into energy, releasing a numerous amount of heat and radiation. This energy can be harnessed for nuclear power plants, which provide a significant portion of the world's energy. Second is medical imaging. The principle of mass energy equivalence is used in medical imaging techniques such as PET scan. In these scans, a small amount of radioactive substance is injected into the body, which emits positions that collide with electrons in the body, producing gamma rays. These gamma rays can be detected and used to create images of the body, internal organs, and tissues. Third one is particle physics. Particle accelerators, such as the Large Hadron Collider (LHC) in Geneva, accelerate subatomic particles in incredibly high speeds, allowing them to collide with each other and produce new particles. The energy of these collisions is calculated using the mass energy equivalence principle. Fourth one is nuclear weapons. When the nuclei of certain isotopes are split or fused, a small amount of mass is converted into energy, releasing a tremendous amount of energy in the form of a nuclear explosion. Fifth one is astronomy. The principle of mass energy equivalence is also used in astronomy to understand the behavior of stars and galaxies. The energy released in nuclear reactions in stars is calculated using the principle, and it is used to explain the phenomena such as supernova and black holes. In conclusion, the special theory of relativity has transformed our understanding of the universe and laid the groundwork for modern physics. Its ideas have far-reaching implications and continue to shape our understanding of the nature of the universe. We can say STR has kept space and time in equal footing, both plays a very crucial role in relativistic motion.
Any question?
There question da
টাইম ডাইলেশন বুলি কৈছিলা টাইম ডাইলেশন মানে কি হয়
The moving time dilation মানে যোনটো আপোনাৰ মুভিং যোনটো বস্তু ইয়াত মানে পাৰ্টিকলটো আপোনাৰ ভেলোচিটি অফ স্পীড অফ লাইটৰ বা ইকুইভেলেন্টলি মুভ কৰে। যেতিয়া মুভ কৰিব যিটো মুভিং যোনজন অবজাৰ্ভাৰ হয়, আনজন অবজাৰ্ভাৰ যদি ৰেষ্টত থাকে, তেওঁ অবজাৰ্ভাৰত সেইজন মানে যিমানখিনি সময় টাইম এক্সপিৰিয়েঞ্চ কৰিব, মুভিং অবজাৰ্ভাৰজনৰ অনুপাতত সেইখিনি টাইম কম হ'ব। Moving clock moves slower.
relative motion or day to day life on one के example दिवा पारने मनो बैठी से ने relativity लो तो relative motion का कथा तो जल्दी कौन रेलवे बोल के किले रोटी का मानूंगा ने रेलवे बोल का मानूंगा तो किधर पर है
निवलो फलो सो यार
গৈ থকা মানুহজনক বাহিৰৰ পৰা উঠি থকা মানুহজনে গৈ থকা কিন্তু তাত গৈ থকা মানুহজনে তাত আৰু এজন মানুহ বহি আছে কেইজন মানুহ কিন্তু তাৰ স্পীড দেখিছে অল আৰ ৰিলেটিভ এই পৃথিৱীখনত সকলো বস্তু ৰিলেটিভ টু দৰ্শনতো গৈ গৈছে বিশেষকৈ ফিলচফিও লৈছে ৰিলেটিভ concept are relative. কোনো বস্তু চিৰস্থায়ী নহয়, কোনো concept নেই। Okay, ই বহুত ভালকে মোৰ মতে বহুত ধুনীয়াকে ক'লে, যথেষ্ট মানে কনটেইন আছে বস্তুটোৰ প্ৰেজেন্টেশ্যনটোত। গতিকে ভাল হৈছে যে কিবা বস্তু থাকিলে আৰু সোধা, নহ'লে ইয়াৰ পিছত সোধা আছে তেওঁ যাব লাগে।
Thank you, Kishanu and Arnab, for your nice presentation about special theory of relativity.